In this session is Chris Steger of Skyhook, and the title of his talk is Scalable Indoor Positioning. Chris.
There we go. Hello, everyone. Glad to be the first one to wish you a good afternoon today. My original title was Scalable Indoor Positioning, but I decided that that was not quite emphatic enough. So I changed it to Massively Scalable Indoor Positioning and how Skyhook attacks that problem. So I'd like to start off today just by giving a little overview of Skyhook's worldview when it comes to positioning. We come from the world of Wi-Fi based positioning, so using beacons of opportunity, Wi-Fi access points that we don't own, we don't have any control over them, and we use asynchronous downlink signals, so we have no real participation on the infrastructure side. We just use the signals received by the clients. And we support any sort of Wi-Fi enabled devices, so something as minimal as an SD card, or a gaming device, all the way up to a smartphone or a laptop. And we do our Wi-Fi positioning on a metro scale. So when we talk about adding coverage, we talk about adding it a city at a time. And the way we do that is through two principal mechanisms of data gathering, one of which is doing driving surveys, and the other is user feedback or crowdsourcing. As I mentioned, some example use cases, different types of devices we have. We're baked into several mobile operating systems, and we're also included in some smartphone apps, dedicated gaming devices, and we provide the turn-by-turn navigation for MapQuest. And with each of these different discrete metro scale units, we provide nearly worldwide coverage, at least much of the developed world, in tens of countries, hundreds of cities. And that surveying was performed by thousands of drivers, not all at once, but over the years, that's how many we've accumulated. And they've driven millions of kilometers, and now we provide location to tens of millions of users using a database of hundreds of millions of access points. So in order to do indoor, we have to do it in a big way in order for it to be a meaningful part of our ecosystem. And indoor presents a unique set of challenges for us. Coming from the world of outdoor surveying, when we talk about indoor, Skyhook has always been able to provide indoor location, but it's been more along the lines of, this is the building you're in. Now, if we want to talk about capital I indoor, then that presents a different set of challenges for us and requires a bit of a paradigm shift. So specifically, when it comes to surveying, if we want to do an indoor survey, it's no longer drivable. The venue owners really don't appreciate that. And the kind of equipment that you need to do an indoor survey is also quite different. When we're operating outdoors, we're primarily able to use sort of commodity GPS equipment. But as soon as you go indoors, the GPS availability is spotty, and then you need to have higher end inertial navigation systems or very advanced GPS. In terms of the operator skill level, when you're surveying outdoors, you basically need someone who can drive and follow directions. Indoors, you need someone who is actively aware of what your equipment is doing, just because it's so difficult to make sure that you're associating the right ground truth location with your scans. And finally, the availability of maps and floor plans is different. It sounds like more standardization is happening in terms of the availability of indoor maps, but it's still sporadic. It varies from country to country, city to city, and across different types of venues. Whereas outdoors, we can generally depend on the availability of maps. So all those things create additional challenges to us when we want to move indoors. And secondly, there's the area of cooperation. Now, when we're outdoors, the owners they generally have no idea that we're even there, the owners of the access points. There are some specific scenarios where that might not be true, such as metro Wi-Fi installations. But for the most part, it doesn't matter to the owners that we have surveyed their access points. We don't need any of their participation or cooperation. And also, when we're surveying a whole city, we don't have a single owner who controls all the access points. That's different in a venue, where we can pretty much count on the venue owner controlling the access points and determining when they move, where they're placed. And differently from our metro scale coverage, the owners of venues are very interested in how we perform in their environment, and we really need them to participate in it just because of the challenges of collecting that data. And that difference, the difference in the level of owner participation and the kind of positioning we need to do is why this area is particularly ripe for standardization. Because we really need to be partners with the venue owners and allow them to participate in the improvement of the coverage in their venues. So we need to give them a way to participate, and we need to make that participation tolerable to them and conform to their needs and address their concerns in terms of managing who owns the data. So we have to be able to support in this standard all different types of systems that might be used for localization. So we have to have sort of a minimal requirements in terms of hardware. We need to be able to control the ownership and accessibility of the information, because otherwise the venue owners don't want to participate. And finally, the end goal of all this is to remove the barriers to entry that prevent the venue owners from wanting to be part of this system. So we have to make it attractive for them, and we have to make it possible for them to participate, no matter what type of venue they have, no matter what sort of skill level or commitment to positioning they're willing to put forward. So with that in mind, we have a very customer-driven, very business-driven technical problem. And this is how we've defined it at Skyhook. So first of all, in terms of accuracy, we have to be able to detect that we're in a venue and seamlessly switch to a venue-level positioning system. And then we need to be able to provide aisle or section-level accuracy. Now, obviously, there are systems and ways to get down to much finer accuracy, but this is sort of the minimum viable product. What we'd like to be able to provide to get the venue owners in the door and get them using indoor positioning. So in order to be useful to them, we like to be able to say, okay, you're in the venue, and here's the basic area within that venue where you are. Now, in terms of scalability, in order to make this a solution that we can roll out on a metro scale, on a worldwide scale, we really need to keep surveying to an absolute minimum and minimize the amount of installations that we ask for from our venue owners. So that means if we can do without dedicated hardware, and if we can minimize the amount of scanning of the venue, then the solution becomes much more scalable. And when we're talking about the minimum viable product that's ultra scalable, then we actually want to go down to zero surveying and zero additional installation. Now, because we're talking about the minimum, it's certainly possible to provide a higher level of service with more participation, more commitment, more resources from the venue owners. But just from the standpoint of getting the most venue owners on board, this is where we start. In terms of compatibility, we want the system to work the same way as other Skyhook positioning. So we rely on downlink signals. We need no participation from the network itself. And we do active scanning. So specifically, that means no promiscuous mode. We don't collect any packets other than probe responses. And finally, the ownership question presents some technical challenges as well, because we can't indiscriminately use feedback. So if we have two next door venues, then they may not want to use their data to help each other. So we have to be sensitive to that and reduce our dependencies on that feedback. So the solution we came up with is one with no surveying. So what's left? We need the venue owners to submit their access point locations. Now, the degree of precision with which they submit those locations is going to determine the degree of precision with which we can position them. And that's another way in which they can participate in improving their own positioning. If they're interested in having really precise precision, then they can do a better job. We don't ask them to install any dedicated hardware, but obviously if they have one access point in a large venue, we're not going to be able to provide very good positioning. So we provide guidelines and say, if you'd like to have good positioning, here is where you would put your access points. Here's about how many you would need. Because we don't do any scanning, we can't do any individual characterization of either the venue or the access points themselves, which is a big paradigm shift for Skyhook because our bread and butter is characterizing each access point in terms of its path loss exponent and its coverage area. But if you don't do scanning, you can't do characterization. So what we have to do instead is use adaptive algorithms that figure it out as they go along. And finally, by keeping this overhead to a minimum, we have a solution that allows maximum scalability. So the barrier to entry is so low that all we need is for venue owners to tell us where their access points are, and they can get started. If they want to make the system better, then that's certainly something we can do with scan data or with more access points, with better positioned access points. But this is enough to get them started. So next I'm going to go through just a couple of quick results, some case studies. The first one is the Skyhook office. We know the venue owners pretty well, so we got good cooperation from them. It's an open plan office with drywall partitions. There are 10 access points there, and it's about 480 square meters. I know the guy who did the access point installations personally, and he was very helpful to us. So this is sort of an extreme case of what we would do if we had full control over a venue, if they followed our guidelines exactly. Now, for an example of a venue where we had no control and they put up access points completely of their own volition, we studied a Home Depot store. Now, you're probably all familiar with Home Depot. It's a large warehouse with very high ceilings, very tall, dense metal shelving. They happen to have 19 access points, which was a surprisingly high number that shows that they are clearly interested in positioning or inventory control within their warehouse. And the total area was a little under 10,000 square meters. So looking at Home Depot, what we have here is a map of the scan locations when we did survey this. So in spite of the fact that our system is designed to be built up without surveying, we test it by surveying, ironically enough. So what we see are the black triangles. Those are the locations of the access points. And then the darker blue areas are the places where we had better positioning performance. And the lighter areas are the areas where we had some trouble. So you see out toward the corners of the building and over here toward the far right. Now, I'd like to highlight that as sort of a teachable moment for our system. It turns out the issue here was an irregularity in the building where the ceiling was lower and they had a different type of shelving. So suddenly we had a very non-uniform propagation environment. And so what we would do in a situation like that is say, well, if you'd like better performance there, just drop in an access point or do some scans for us. And we can take you from the very base level of performance up to a more uniform quality across the building. But even with those points considered, we got down to a median error of about 6.7 meters. So in Home Depot, that translates to about an aisle and a half. So that gets you pretty close. And we were able to do that without a site survey. So with just ground truth knowledge of the access points. So that was pretty impressive. And then when we moved to our own office, considerably smaller and with a higher density of access points, we explored sort of the limits of this approach. So we got down to a median error of about 3.5 meters. So that was down to about cube level. You could navigate around our office and find your way to a specific person in the office with this system without having actually done a site survey. So what we've learned so far is that the AP placement is really essential. So once again, with our venue partners, we can give them guidelines on how to produce better positions. So it's good for them to get the access points out to the perimeter of their venue, both from the standpoint of making sure we have signal power everywhere and keeping the access points non-collinear from any given scan location. Now, that's clearly not how you would do it if you were doing coverage just for data. If you just wanted to provide data coverage, then you would have more central access point locations. You would never put them out at the edge of the building. So that gives the venue owners the freedom to focus on improving positioning if that's what they want. But we can still provide a basic level of coverage if they just want to use the access points exactly as they are. Now, in order to get really top performance, then we multiply the number of access points by 2 to 4 times, which is really not very much of a problem considering that the price of access points is very low and we don't actually need a data connection. Recall that we're using downlink signals, so all you need to do is plug the access points into power and you're good to go. And the rough scaling that we found with access point density is that the median error you get is approximately 1/3 of the AP to AP spacing. So in Home Depot, we had about 20 meter spacing. We got down to about 7 meters error. In the Skyhook office, we had about 10 meter spacing. We got down to 3.5 meters error. So that's just the rough equation for how much additional hardware you'd have to add in order to get to different performance thresholds. And overall, across all the venues that we've seen so far, which includes several that I haven't shown here, including an IKEA, like we saw earlier, we've seen errors between 3 and 10 meters. And that was achieved with minimal overhead. So all the hard work was being done in the algorithms at the client side. So real-time characterization of the environment. And those results can be extended and improved just by adding more access points, by positioning the access points better, or by actually doing a scan survey in areas where we're interested in really top-level performance. Thank you very much.